Good morning, men. Now we're going to address question number 2, quadratic functions 1 homework. All right, for the given equation and graph, do each of the following. So we have the quadratic equation that maps out on the regular old grid graph, maps out a quadratic function. Okay, what is the difference between this one and number 1? And how does the function equation look different? How does the function graph look different? Okay, we'll go through and analyze it here once again. What is domain and range? Where's the vertex? Where does it hit the y-axis? Where does it hit the x-axis? Intersects. And what is the axis of symmetry? Okay, the domain, once again, all x values will be used. Quadratic equation, domain, negative infinity to infinity. The range, though, you got to be careful. What are the y values that this equation uses? Well, it goes all the way to negative infinity, addresses every y value to negative infinity, but it comes up and peaks right there at the vertex, and you got to make sure you use the little square bracket, okay, in my math lab. On the homework, make sure you use comma, the y coordinate of the vertex, with the little square bracket, okay? Coordinates of the vertex. Once again, here you got your h and your k. We'll talk about more about this later, but you can see it right there. Right next to the x, change the sign. 4, 8 is the vertex. 8 being right here at k value. All right. Axis of symmetry, we know that. That is the line x equals, and that x value of the vertex. X equals 4. All right. Now, we're going to spend just a little more time on finding the y-intercept and the x-intercept. Okay, pay attention right here, guys. The y-intercept will be where x equals 0. So, f of x and x will be 0. Input 0 into x, minus 2 times 0 minus 4 squared plus 8. Okay, and just work that out. Minus 2 times negative 4 squared plus 8 equals minus 2 times 16 plus 8. So now you've found, using the quadratic equation, the equation of the function you have there, you have found accurately, because on the graph it was off the graph, and you're not going to want to graph every time, so you can find that y-intercept by plugging in 0 for x and solving. Okay, look at the x-intercepts. X-intercepts. This is a little more fun. I want to find where the function has points where y equals 0 will be the x-intercept. So substitute in on this side. I have, write the equation like this if you want to, minus 2x minus 4 plus 8. This is going to take a second. All right, so we're going to plug in 0 here. 0 equals minus 2 times x minus 4 squared plus 8. All right, we could take the 8 to the other side. We got minus 8, and I'll divide by minus 2. Divided by minus 2. I know I'm doing 2 steps at once. You practice it, you'll figure it out. X minus 4 squared. So this will be 4 equals x minus 4 squared. Oops, I'll flip it over now with this, okay? Take the square root of both sides. And remember, when you take the square root, you get plus or minus. 4 equals x minus 4. Move that minus 4 to the other side. You got 4 plus or minus 2, square root of 4 is 2, equals x. So you have 2 answers for x. X equals 2, and x equals 4 plus 2, 6. So that's your x-intercepts. And now you've analyzed this function. You got the x-intercepts, you know the y-intercept, axis of symmetry, and the vertex, and the domain and range. Thank you guys. Good luck.